Hi, I'm Max. This is the second part of the differentiation basic lesson. We discussed earlier. What is differentiation? Why need differentiation? What is delta means in differentiation? What is gradient function? What is derived function or the derivative? Differentiation notation. Okay. Let's talk about the other things in this lesson. First of all, we are going to observe the general gradient function. Let's consider any curve with equation y equals fx, taking 2 points on the curve a and b, like this. So, therefore, the gradient of a, b is given by this equation. If you don't know how we get the gradient of a, b, please watch Differentiation Basic Part 1. The link in the description. Now, the delta x is close to 0, the delta y by delta x is changed to dy by dx. So, then, we can obtain the general gradient function like this. Now, you already know, we only need the function of the curve to find the gradient function of the curve, and the x coordinates to find the gradient at that point. Let's see an example. Find the derivation of the given function. Pause the video and try to do it. Okay. You know, the fx is equals to 1 over x, and, you know, how to get small increase of fx equals fx plus delta x, like this. Now, we need to find this part in general gradient function, like this. After that, you can obtain this. Hence, finding the limits, delta x is close to 0. Then, you can get the gradient function, or the derivative. See? This is how to differentiate with general gradient function. There are so much easy ways to differentiate, but first, you should get the basic knowledge about how to differentiate using basic methods. Later, I will teach you easy methods. After that, you can differentiate functions by just looking at them. I put some exercises for you. The link in the description. Now you can do the exercise number 2. Okay. Now, we are going to talk about how to differentiating xn with respect to x. Look at this table. From this table, it appears that when we differentiate a power of x, we multiply by the power, and then reduce the power by 1. So, if y equals xn, we can get an equation like this. Remember this equation. It is easy to apply, and makes the task of differentiating a power of x very much simpler. Now, see some examples. Okay, I will give another example, and I will give time to find the answer. Pause the video and try to find the answers. Okay, let's see the answers. Okay, now you can do the exercise number 3. What will happen if we differentiating a constant? Consider the equation y equals to 5. Graphically, this is a horizontal straight line, and its gradient is 0. That means dy by dx equals to 0. Now you can understand, if we differentiate any constant, then we get 0 value. Remember this. Let's see how to differentiating a linear function of x. So, let's get a graph of the equation y equals kx, where k is a constant, so we can see it is a straight line with line gradient k. So, we are going to differentiating kx. Before that, we should rewrite them like this. To differentiate kx, we should put the constant outside. Now we know how to differentiate x. This conclusion applies, in fact, to a constant multiple of any function of x. Let's see some examples. Now, we can obtain a general equation for that, like this. Remember this. If a function of x, which contains a number of different terms, can be differentiated term by term, applying the basic rule to each term. See this example. Okay, now try to do the exercise number 4. someone can have a problem with finding, differentiating products, and fractions. It's as simple, we can use all the rules that we discussed previously to the differentiating of expression containing products or quotients, provided that at this stage they are multiplied out or divided into separate terms. Okay, let's get to examples. If y equals this, we should expand this into separate terms. Then you can apply differentiation rules to each terms. Likewise, next example also separate into multiple terms like this. Then you can differentiate like this. Okay, now you can practice these things in exercise number 5. Okay, now we are going to talk about how to find gradients of tangents and normals. If the equation of a curve is known and the gradient function can be found, then the gradient m, say, at a particular point a on that curve can be calculated. This is also gradient of the tangent to the curve at a. The normal at a is perpendicular to the tangent at a. Therefore its gradient is -1 over m. Let's see some examples. In this case, they give us the function of the curve. So, we can simply differentiate it like this. Then, we need to add the coordinates to the gradient function to get the gradient of the tangent at given point. Someone can have a problem with this, adding coordinates to the gradient function. This is s versus t curve. So, we know s is equals to y, and the t is equals to x. So, just add the x coordinates to the gradient function. The x coordinates is the first one. Okay, now you know how to get the gradient of the tangent. This is the m value. Now, getting -1 over m, then, you can get the gradient of the normal at given point. Let's look at another example. This time, we have the function, and also the gradient of a point, to find the coordinates of that point. You know that, how to get the gradient function. Then, that is equals to the given gradient at that point. Solving that equation, we can get the x coordinates of that point. There can be more point at same gradient. Then, adding these coordinates to the function, we can find the coordinates of the points what we need. Now, you can do exercise number 6. We'll discuss more things about tangents, normal, and stationary point in later video. For that lesson, we need the differentiation knowledge. So practice these things. I put some mixed exercise for you to practice differentiation. Okay, this is the end of the lesson. I hope you all understand about basic differentiation and why we need that. But we have more to learn about differentiation. So, other things I will teach you later. If there is something you do not understand, leave a comment. I will explain to you all the exercise and answers in my drive for now. I will put those exercises some organized way in a blog later. For now, use the given links. I create a FB page for Maths with Max, so you can contact me directly if you have a question. If you have time, please give me feedback, because it will help me to avoid some mistakes and improve the video content quality. It's nice if you have any suggestion for my videos. I hope to give lessons every week, because it's take minimum a week to create a video like this for me. I'm happy if you subscribe my channel. Okay. Goodbye for now everyone, I will see you in my next video. Thank you for joining with me.